Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over problems 25 to 28 of the January 2016 Algebra 1 Common Core New York Regents exam. The focus of this presentation is to make sure that you really understand the concepts behind the problems that are presented on this test so that you can do well on the upcoming exam. Okay, if you would just like worked out solutions with no audio, you can click on this link right here so you can see how the problems are done without any audio. Alright, let's take a look at problem 25. It reads, the function t of x is shown in the table below. So we have the function t of x right here. Question, determine whether t of x is linear or exponential. Explain your answer. So one thing you want to recall is that linear functions have a constant rate of change. And exponential functions, on the other hand, have increasing or decreasing rates of change. Basically, a variable rate of change. What is another word for rate of change? Another word for rate of change is the slope of a line through 2 points. Okay? Now, what we're going to do here is we're going to pair up the points we have here into intervals, and then we're going to calculate the rate of change on each interval to see if they're constant or variable, either increasing or decreasing. Okay, so the first interval we have, we're going from -3 all the way to -1. Okay, so that's interval 1, and then from -1 to 1, that's the second interval, interval 2. And then from 1 to 3, that's interval 3. And then from 3 to 5, that's interval 4. Alright, so what we're going to be doing is finding the rate of change in each interval, taking a pair of coordinates at a time, and then we're going to compare them with one another. Alright, so let's go ahead and take a look at the first interval. So remember, rate of change, it's called ROC, is the same thing as the slope, which is y2 minus y1 divided by x2 minus x1. Alright, remember, rise over run. That's your rate of change or slope. Alright, let's do the first interval. So the first interval, we're going from -3 all the way to 1. Okay, so that's interval 1 right there. So the first pair of coordinate points are our ones, x1, y1, and this is x2, y2. Let's do it. So m1, the slope of the first interval, the rate of change there is y2, 7.5 minus y1, 10, divided by x2, -1 minus x1, -3. Okay, so remember, y2 and x2 are on the bottom, and then the ones are on top. Okay, so that's how you do it. So if you subtract here, we have -2.5 divided by minus times minus. You slash and dash. That becomes a plus. Minus times minus is plus. So we have 1 plus 3. I'm sorry, -1 plus 3, that's 2. Okay, and then if you divide these two numbers, you end up with -1.25. You can do this with your calculator, that's not a problem. Okay, so this is the rate of change from the first interval, from -3 to -1. Now let's check the rate of change for the second interval. Okay, m1, I'm sorry, the slope of the second interval is, the number of the second interval is 2, so we're going to call that m2. So let's do that, change colors here. So for the second interval, we are going from here to there. Okay, so let's call that m2. So what is the slope on the second interval there? So m2 is going to be y2 minus y1, so we're going to do 5 minus 7.5, y2 minus y1, that's a rise, divided by x2, 1 minus x1, -1. Remember, we're just focusing on these pair of coordinates right here, interval 2. Let's compute the slope or rate of change. 5 minus 7.5 is negative 2.5, divided by 1 minus minus 1, slash and dash again. Minus times minus is plus. So what we have downstairs is 1 plus 1, which is 2. Negative 2.5 over 2, you can divide that by hand or with your calculator. You end up with negative 1.25. Let's pause for a second. What do you notice? The rate of change is constant. So it looks like our answer is a linear function, okay? If this changed, then it's automatically exponential. Let's just do one more interval just for confirmation. Even though this is sufficient, let's do one more interval, okay? You don't have to do everything. So let's do the third interval from 1 all the way to 3, okay? Let's see what the rate of change or slope is there. So for the third interval, M3, the rate of change is Y2. Now, what is Y2? We're looking at this interval right here. What is Y2? Y2 is the one on the bottom, right? 2.5 minus Y1, which is 5, divided by X2. Which one is X2? The one on the bottom, right? 3 minus 1. In the numerator, 2.5 minus 5 is negative 2.5. And in the denominator, 3 minus 1 is 2. If we divide it, we end up with negative 1.25. What do we notice? All the rate of change are the same. Okay? So, is T of x linear or exponential? T of x is an exponent, it's a linear, where did that come from? Is a linear function. Okay, so T of x is a linear function. Alright, so just stating the answer, you don't get full credit. Notice what is stated here. You have to explain. Okay? You have to state the explanation. So what is our explanation? T of x is a linear function. Reason because the rate of change is constant. Alright? T of x is a linear function because the rate of change is constant. So you always have to add the justification anytime that you are asked for it in order to get full credit. Okay, let's take a look at number 26. It reads, Marcel claims that the graph below represents a function. So we have to state whether Marcel is correct and justify our answer. So two things here. In order to get 2 points, we have to state if Marcel is correct or not, and then justify our answer. Now, one thing to note is that graphs of functions pass the vertical line test, okay? What is the vertical line test? If you take a vertical line and swipe it through the entire domain of a function, the vertical line must intersect the function at most 1 point in the entire domain. If it intersects at more than 1 point, the function fails the vertical line test and it is not, the graph fails the vertical line test and it is not a function. Okay? Now, just some tips to keep in mind. How do you know if a function is, how do you know if a relation is a function or not? Well, if you're given a graph like we have here, all you use is the vertical line test, okay? It must not intersect more than once. If you're given a table, focus on the x's. There should be no repetition in the x's. If you're given an equation, focus on the y's. Make sure that the y in the equation is not squared, all right? If you're given ordered pairs, note that you want to focus on the x's. Ensure that you have no repetition in the x's. Okay, so that's just a little tip for you to determine if a relation is a function or not. Okay, so now for this one, let's do our vertical line test. I'm going to take this vertical line and I'm going to swipe it across the entire domain of this function. And what I'm going to be checking for is that the graph intersects this vertical line at exactly 1 point for the entire domain, nothing more. Okay, if it goes more than one point of intersection, then automatically it fails the test and it's not a function. All right, so let's do it. So we have 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. When I'm talking about intersection, this is what I'm looking at. Where the line hits the function. You see that? That's the point of intersection there. Okay, so it's looking good. Let's keep on going. We have to do the entire domain. So 1, 1, 1, 1, 1, 1, 1, once, 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 once. Uh-oh. We have a problem here. What do you notice? At the point right here where you have the jump from this function to the other, how many points are on this vertical line? 2 points. Is that good or is that bad? That is very bad. Okay, remember, the vertical line test cannot intersect more than 1 point on the graph, or else it fails. So this clearly shows that this relation right here, this graph, is not a function because a vertical line intersects the graph at more than 1 point, so it fails the vertical line test. Is Marcel correct? Marcel said it is a function. Is this a function? No. So our answer is Marcel is not correct. Is that sufficient? No, we have to state our justification, okay? Why is Marcel incorrect? Well, because the graph fails the vertical line test. Line test. It is not a function. Okay? So just stating that it fails the vertical line test for a justification is sufficient. You don't have to go into detail about it intersects more than one. You could do that if you want, but that's being excessive, all right? Do a vertical line test, state that Marcel is incorrect, you get 1 point, and then state your justification. You get another point and get full credit for this question. All right, let's take a look at problem 27. We are to solve this equation for y. So we have y, quantity y minus 3 squared equals 4y minus 12. All right, now this looks like a quadratic equation, okay? But in order for us to know for certainty, we need to get rid of this parenthesis. It's in the way. All right, so to get rid of this parenthesis, we have to expand this squared quantity. So what is y minus 3 squared? Now this is a common mistake students make. They say, oh, you know what, y minus 3 squared, I'm going to just distribute the power to the y and the 3. So this becomes y squared minus 9. Is that correct? That is incorrect. Okay, so watch out for that mistake. If you have a quantity square, what you do is you have to multiply that quantity by itself, like that. Okay? That's how you expand binomials that are raised to a power. Okay, times 4y minus 12. So here we're going to distribute twice, or FOIL it out since we're dealing with the product of binomials. So we go first, outer, inner, and then last. Okay? Alright, let's expand it. Y times y is y squared. Y times 3 is negative 3y. Negative 3 times y is negative 3y. Plus 9. Remember, minus times minus is plus. Equals 4y minus 12. Now, what kind of equation is this? The highest degree is 2, so this is a quadratic equation. How do you solve quadratic equation? Well, there are different methods. You can solve it by graphing, you can solve it by factoring, completing the square, or the quadratic formula. All right, but in whichever case you want to do, you want to put it in standard form, okay? Other than graphing. So let's put this in standard form in order to solve this algebraically, okay? So what is that? What is standard form? The standard form for the equation for a quadratic equation just involves setting it equal to 0 with the powers in descending order. Okay, well, let's combine like terms here. We can combine these two. We have y squared minus 6y plus 9 equals 4y minus 12. So we want to put it in standard form. We want to set it equal to 0. Subtract 4y from both sides. And then the 12, how do we take care of that? Minus 12, you do the opposite, right? Add 12 to both sides. So that gives us y squared. Same sign, you add and keep the sign, minus 10y plus 21 equals 0. What have we accomplished thus far? We have put the equation in standard form. Okay, now we're going to start trying out our different solving techniques for quadratic to see what works. The easiest is factoring by grouping. Okay, so let's try and see if this equation is factorable, this expression right here to the left. If it is factorable, then that's good. If it's not factorable, then we have to use other methods. Remember, the quadratic formula always works. Okay, all right, so we're going to use the x game or the AC method here. You multiply a is the coefficient of y squared. It's 1, okay? That's a multiplicative identity. That's why you don't have to put it there. So you can just put the 1 there if you don't have any number, okay? Because 1 times y squared is just y squared. So AC goes on top. 1 times 21 is 21. And then b goes on the bottom, negative 10. This is called a game because you have to think about what two numbers multiply to give you the number on the top and add to give you the number on the bottom. So what is the case here? What are the two numbers? 7 times 3 gives me 21, but 7 plus 3 gives me positive 10. I have a negative 10 here. We have a problem. How can we fix that? What if I make both of them negative? Negative 7 times negative 3 is positive 21. Negative 7 minus 3 is negative 10. Perfect. That's exactly what we want. Okay? Now, another thing you want to note is that in this problem, a is equal to 1. What does that mean? It means that you can jump from this x game to the factored state. If a is not equal to 1, you must factor by grouping or you run into complications. All right, so we can jump into the factored state, y minus, take the first number, 7, times y minus 3, 0, equals 0. Now we're going to use the zero product property. If the product of two quantities is 0, that means either the first is 0 or the second is 0. Okay? Now, let's solve this. The first equation, just add 7 to both sides, is a one-step equation. So we have y equals 7 as our answer. The second one, you add 3 to both sides, and you have y equals 3 as your second answer. Okay, so our solutions are y equals, you can put it in ordered pair, I'm sorry, not ordered pair, in set notation, 3 and 7. Okay, or you can say y equals 3 and y equals 7. Those are our answers. All right, let's take a look at problem number 28. It says the graph below shows the variation in the average temperature of Earth's surface from 1950 to 2000, according to one source. Okay, so we have the graph here that shows the average variation in temperature, the y-axis against the years from 1950 to 2000. Now the question is, during which years did the temperature variation change the most per unit time? Explain how you determined your answer. Okay, so this problem is a little bit tricky. You have to really understand what the question is asking you. Okay, so in this problem, you're asked to determine which years the temperature variation changed the most. So we're not looking at change in year per se. We're looking at the change in the temperature. Okay? So I have a little note here. When you're looking at the size or the magnitude of a change, basically the most, we're looking for the biggest increase or decrease for identical intervals. So when did the temperature rise or fall the most for each interval? We don't care about the sign here, okay? It's kind of like a scalar quantity, a terminology used in physics. We're not looking at the sign, we're just looking at the size, okay? So what we're going to be doing is we're going to be looking at each 5-year interval. We're going to be looking at how much the temperature rose or fell, and then the biggest rise or fall for any interval will be our correct answer, okay? All right, so how many intervals do we have here? We're looking at 5-year intervals, okay? So this is interval 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, you might think that you have a lot of intervals to look at, but it's nice because from interval 6 to 10, they all have identical slopes. So it should be easy to compute the rise there. All right, so remember, we're not looking for the slope, we're looking for the rise or fall. Which interval did you have the biggest rise or the biggest fall? Okay, so what we're looking for in essence is the absolute value of the change in y. That's what we're looking at, okay? So this is our y-axis. Now let's take a look at this coordinate system, the calibration of our y-axis right here. What you notice is that 2 tick marks is equivalent to 0.1. So what is 1 tick mark? 1 tick mark is half of that, which is 0.05. All right, so 1 tick mark rise or fall is plus or minus plus or minus 0.05. Okay? All right, let's keep that in mind. For year number 1, what was the first interval, not year 1, from 1950 to 1955? For the first interval, what was the rise? From this point to this point, what do you notice? It's horizontal, which means you have 0 rise. Okay, so we have the temperature variation for that interval was 0. Okay, so in this case, we have delta y. Change in the temperature, this is called delta y. We don't have to put the absolute value. Change in the temperature is equal to 0. Now let's take a look at the second interval. Oh, we have a rise there. Okay, so for the second interval, the rise is, here you are at negative 0.05 and you rose to 0. So how high did you go? You had a rise of what? Of 0.05, because if you subtract 0 from negative 0.05, you get 0.05. So that was a rise. Okay, either you go up, count it, or you subtract. So your rise there was 0.05. Okay, let's look at the third time interval. Third time interval, what do you notice happening here? For the third time interval, there was a drop. You drop from 0 all the way down here. This is negative 0.15. Okay, remember every box is 0.05. So if you triple that, you get negative 0.15. Okay, so our fall in this case for the third time interval from 1960 to 1965 is negative 0.15. All right, let's take a look at interval 4. What happened in interval 4? You had a rise. The rise is just by 1 tick mark. What is 1 tick mark equivalent to? 0.05. Okay, so the temperature variation there, we had a rise of 0.05. Notice interval 2 and interval 4 are parallel, right? So you shouldn't be surprised to see that they have the same rise. How about interval 5? It looks just like 1, huh? So what do you think the rise would be there? It's a horizontal line. Horizontal lines have zero rise. Okay, so it didn't go up or down, so it stays flat, no change there. Zero, that's the rise for interval 5. Okay, now for interval 6 through 10, since they're all on the same line segment, they all have the same slope. The entire interval here, you have identical rises. Okay, so for interval 6, you have a rise of what? You go up 1, 2. Each tick mark is 0.05, so 1, 2 is a rise of 1. Interval 7, what do you think that's going to be? Interval 7, 1, 2, that's a rise of 1. Interval 8, what do you have? 1, 2, that's a rise of, why am I calling it 1? Here is 0.1, okay? So a rise of 0.1, 0.1, and then interval 8, 0.1. Interval 9, the same thing. You have a rise of 0.1, because you see 1, 2. And then interval 10, you have a rise of 0.1. Okay? So ignoring the sign, remember we're just focusing on the size of the numbers. Where do you have the biggest rise or fall? Where do you have the biggest number? The biggest number here, if you take the absolute value of all these numbers, is 3. Yeah. 0.15 is the biggest number. Okay? So interval 3 is from 1965 to 1970. That is no, that's right. It's from 1960 to 1965. Okay, that's where you had the biggest change in temperature. It was a fall. Okay, you had a fall of 0.15 degrees Celsius. Okay? All right, let's go ahead and write down our answer. So let's determine which years. So the years are from 1960 to 1965. There was the most change in temperature variation. Okay, temperature variation. Why is that the case? Because in that interval, there was the greatest change in temperature of what? What was the change in temperature here? The greatest change in temperature. There was the greatest change in temperature of 0.15, okay? Whereas every other interval had what? Whereas every other interval had a change of what? Had a change of 0.1, 0.05, or 0. Okay, which is less than 0.15. Okay, which are less than. Anyway, so that's basically the answer, identifying the year, and if you want to get full credit, you'll have to explain why that is the case. And the argument here is that we have the biggest change. It was a fall in that interval compared to every other interval where we just had a change of either 0 or 0.1 or 0.05. Okay, so that's that. Thanks so much for taking the time to watch this presentation. We appreciate it. If you found the contents of this tutorial beneficial to you, do give us a thumbs up. We'll appreciate the positive feedback. Do not forget to subscribe to our channel for updates to the remainder of this review series. If you have any questions about this tutorial or any problems related to the Regents exam, Just post your question in the comment section below and we'll be glad to assist you as soon as possible. More clips, including the transcripts to this video, can be found on math.serve.com under test prep. Thanks again for watching and have a wonderful day.